Mind you, though, that it is only true if we have a situation of pure ρ. So we can now substitute in there the values that we have for a solid cylinder. If we have a solid cylinder, then the moment of inertia about this axis to the center of mass, which I've called Q, equals 1/2 mr squared. And if I substitute that in here, notice that all my mr squares go away. I get 1 plus 1/2, which is 1.5 upside down, it becomes 2/3. So A equals 2/3 times G times the sine of beta. There is no N, there is no L, and there is no R. So if I have two cylinders, solid cylinders, with totally different mass, totally different radii, totally different length, and they have a race, neither one wins. It's very non-intuitive. Every time that I see it, I find it kind of amazing. Notice that everything disappears. M, R, and L disappear. So those of you who said that if I take two cylinders with the same mass, different radii, those of you who said that there is no winner, there is no loser, they were correct. But even more amazing is that even the mass you can change. You can change anything as long as the two cylinders are solid. That's what matters. So if we take a hollow cylinder, then the moment of inertia about this axis to the center of mass, so Q, if really most of the mass is really at the surface, then it's very close to mr squared. And then the acceleration, if I substitute in here mr squared, I get a 2 there, equals 1/2 times G times sine beta. So this acceleration is less than this one. So the hollow cylinder will lose in any race against a solid cylinder, regardless of mass, regardless of radius, regardless of length. And I want to show that to you. We have a setup here, and I'll try to show that to you also on the screen there. But for those of you who are sitting close, it's probably much better that you just look at the demonstration right here. I have here, to start with, a very heavy cylinder made of brass, and this one is made of aluminum. They have very different masses, same radii, same length. Should make no difference. There should be no winner. There should be no loser. I'm going to start them off at the same time. I hope you can see that there. This is the starting point. You can lower it a little. I will count down 3 to 0, and then you can see that they reach the bottom almost at the same time. So very different in mass. The mass difference is at least a factor of 3. All other dimensions are the same. 3, 2, 1, 0. Completely in unison. Not intuitive for me. Now I have one that has a very small radius compared to this one. This is a small aluminum rod. Maybe you can see it here. Television. This is way more heavy, almost 30 times heavier. Should make no difference. As long as it's solid, should make no difference. No winner, no loser. Radii are different, masses are different. Should make no difference. Okay? There we start the race. 3, 2, 1, 0. And they hit the bottom at the same time. But now, here I have a hollow one. You better believe it, that it's hollow. So now all the mass is at the circumference. And now it takes more time. Now the acceleration, as you will see, is 1/2 times G sine beta. In the other case, it was 2/3. And you may want to think about it tonight. Why this one takes more? It has to do, of course, with the moment of inertia. But again, it's independent of mass, radius, and length. So it's purely a matter of geometry. This one is going to be the loser. And this one, regardless of mass or length, is going to be the winner. So you see them, one is hollow, one is not. This is very light, this is very heavy. I'll put the hollow one on your side. Three, 2, 1, 0. The hollow one lost and even fell on the floor. Yeah, I find these things always quite amazing, that nature works this way, and I'm impressed that most of you, or many of you, had the right intuition when they said it would make no difference for the two solid cylinders.